völlig wurscht, Herr Ziegler. Grüß Gott, vielen herzlichen Dank.
Ich kriege meine Donation.
Wo Sie ihn können. Hallo. Guten Tag. Sie fangen an. Ohne Sie geht nichts. Ja, ich habe das aber nicht geschafft. Ich habe das dem Ding gesagt, es hat es aber nicht beeindruckt. Manchmal, das geht wieder weg oder wenn man dann eine neue Version auflädt, dann muss man es wieder ein... Ist mir wurscht. Sie wissen, da muss man so... Halt nicht, bleib da.
Nicht, was habe ich da? Nee, ich habe nur die Brille hier drin. Ja.
Halt, jetzt muss man das nicht klar.
Vielen Dank.
Vergesst du noch eine Kleinigkeit? Als Sie gerade bei Urkunden sind, wir dann meinen Sie überreichen die Urkunde.
Ja, habe ich gerade gehört.
Ja, nicht, müssen wir den zusammen machen, das ist doch Quatsch. Nein,
haben wir noch,
Sie überreichen die Urkunde, ich stehe daneben, das reicht doch.
haben wir noch irgendwo...
Also, ja, wir freuen uns, wenn Sie das machen.
Ich würde den gerne noch loswerden.
Ich glaube,
Sie kommen im Papier.
Naja, ob das besser ist, weiß ich nicht, aber ich kann halt ad hoc mal reinschreiben.
Ja, ja.
Also das ist...
Sie haben das dann noch ausgeschaltet, dass dann der Screensaver angeht.
Ich lege es erstmal dahin.
Das passiert nicht, aber
vielleicht denken wir ja
nachher,
nachher, nee, mach noch mal ein Stück.
und dann sehen Sie mich da oben, wenn ich dann so mache, dann hat sich das Format gedreht.
Schadet ja
Ja.
nicht.
Du willst es so analog
Naja, verklebe ich hier noch die Stühle.
Ja, ich werde es wahrscheinlich auch analog hinkriegen. Also wenn das Ding kaputt geht, kriege ich auch die Rede zu Ende.
Ich spiele da draußen Fußball.
Ja,
aber das ist irgendwie, das geht immer so halb ab, das ist ein bisschen blöd.
Nein, ist wurscht, also das kriegen wir schon hin. Das ist schön, das machen wir immer so, die Stimmung ist gut.
Wir haben das jetzt
Ja.
mal, wo wir die Frage aufgeworfen bekommen, ich habe selber als Redebeschäftigter gesagt, Englisch oder Deutsch,
Ja, ja.
Ich mache Deutsch, ich mache auch Deutsch, ich mache ein paar Behauptungen.
Ja. Nee, ist okay. Nee, weil ich werde mich ja so
sehr gut,
bewegen.
Das ist ganz toll. Ich hab auch ein paar englische Brocken drinnen. Ja, das darfst du gerne nicht. Aber ich bin ja angewiesen, dass man eigentlich in Deutsch macht, aber aus Höflichkeit habe ich halt... Von mir aus könnte man das ja ganz auf Englisch machen. Morgen mache ich alles in Englisch. Also. Nein, Sie haben ja recht, wir haben lange darüber diskutiert und haben gesagt, das kann man nicht eindeutig entscheiden. Und darum ist ein Gemisch wahrscheinlich die richtige Lösung. Also. Ja.
Ladies and gentlemen, dear President Schlögl, lieber Helmut, as I see the former president of the Humboldt Foundation here, dear Minister of State Güler, dear colleague Walczak, liebe Humboldtianerinnen und Humboldtianer, it's difficult in German, dear Humboldtians, if that works in English, whatever it is, dear colleagues and friends, a very warm guten Abend and bienvenue, welcome, willkommen an der Freien Universität Berlin. It's wonderful to have you here again. I think it feels like family. Perhaps also, as my grandfather always said, I started on my own and now I'm so many, is what he said with his children and grandchildren and so on. This is so many of you here, and it's wonderful to have you all here. And I can say welcome again, as over the years it has developed into a good and stable tradition to host the Jahrestagung of the Alexander von Humboldt-Stiftung at our Henry Ford building, which I think also is a wonderful setting to do this. This was described as in den weltpolitischen Turbulenzen auf Bewährte setzen, in an email that we got sort of inviting to host this again, counting on the well-known in troublesome times. This is how the meeting was announced to us. Well, I guess it's not the content that will be well known to you, as you will need new people and you will get a lot of new input and you will learn new things, and possibly from cancer research as the festive lecture today to whatever your own subjects may be. But what is well known is the location and the setting that can provide stability and continuity to the foundation, and if that's the offer, we'll be happy to do that. So in that sense, to the Humboldt Foundation, welcome again. Only 2 days ago, I opened a reception for the International Week at Freie Universität here in this building, or more precisely, in front of this building out there, where there's no now party and there will be party, and where 62 years ago, tomorrow I think, John F. Kennedy gave his famous university lecture, where he told this university and any university what we must do is to educate citizens of the world, and not only skilled accountants and corporation lawyers. That's what he said. Citizens of the world, and I think this has to be the mission for all of you and for all of us. On that night 2 days ago, I also talked about Immanuel Kant, the philosopher, his way of seeing and describing the world, a world which he himself had seen of only tiny, tiny little parts of. So as for the philosopher, he didn't travel, and for all of his life, he hadn't been further away from his home in Königsberg, what's now Kaliningrad, for more than 15 kilometers. Getting 15 kilometers away from home is definitely not our and not the Humboldt concept of going to see the world. The Humboldt concept, indeed, if you look at the Humboldt brothers, and especially Alexander von Humboldt, they were pretty different in that regard. Alexander traveled across the globe for years, especially the Americas, and he did things that were not necessarily natural for European aristocrats of those days. He researched, he documented, he sent his stuff to Berlin, and he really wanted to understand the core and the functioning of things. He didn't think within the framework of national borders. He didn't spread nationalism or populism. He managed to learn indigenous languages in South America, spoke out against slavery, and supported religious freedom. Alexander von Humboldt was politically very liberal, or let's say it with a word that is simpler and clearer, he was very free. And perhaps also in that context, and also as I see at least one rainbow flag here in the room, we will raise the rainbow flag out there as it's Pride Month tomorrow. That's also part of what that freedom is here and here at the university. But frei, free, and Humboldt are two terms that also have become very popular even among Berlin universities after the Second World War. You may know that one university adopted Humboldt's name for itself. The other one, this one here, went for one of the central characteristics when this was founded. This was supposed to be a free university in the west of the city. Now we could discuss now how much Humboldt there is now in Freie Universität here and how much free is in Humboldt University on the other side of the city, but perhaps that is not really our topic. What is our topic though? What is Freie Universität Berlin's topic, and the reason why we are happy to have you all here tonight? What about Alexander from Humboldt inspires us today and helps us to manage our modern world's challenges and problems? Big challenges, big problems. And yes, there's a lot of Alexander von Humboldt's attitude that we do embody at Freie Universität. As a side note, I really like a quotation by Alexander von Humboldt that also shows a sense of irony, which sometimes helps, and how serious or non-serious he was about German nationalism. He's quoted as having said, "Die Deutschen brauchen für jede Dummheit 200 Jahre, 100 sie zu begehen and 100 sie einzusehen." So the Germans need 200 years for every stupidity, 100 years to do it, and the second 100 years to realize it. Two questions about it. One is perhaps there's another 100 years to try and repair that stupidity, and the other insight might be perhaps that's not really too specific about the Germans. There's lots of stupidities done over the centuries all around. Let's look at it. We can argue a lot about that. We can also argue whether 100 years is realistic for committing stupidities to realizing them or for repairing them, whether this is slow or fast, whether it's good to invest another 100 years to repair the damage once you've done it, and whether this is to the point for the stupidities and atrocities that we see in world politics these days. And of course, whether, as Humboldt suggested, this is particularly German. Instead, I suggest we won't talk about stupidities, but rather about smart things, how to prevent mistakes and stupidities and atrocities, and how to deal with them otherwise. Dear Humboldtianerinnen and Humboldtianer, you do have great potential for all of this, and with potential comes responsibility, as always, a potential and a responsibility that's needed when looking at the world around us and at what is not working well on global scales. Academia must and can compensate here. In that sense, also, I wish you inspiring exchange and dialogue. Take care, and thank you for coming.
Dankeschön. Liebe Humboldtianerinnen, liebe Humboldtianer, liebe Begleiterinnen und Begleiter, liebe Familien, liebe Gastgeberinnen und Gastgeber des Netzwerks, liebe Fachvertreter, Lieber Helmut, danke, dass du da bist. Ladies and gentlemen, a very warm welcome from my side. I have the honor to welcome you here on behalf of the Alexander von Humboldt Foundation, and I would like particularly also to include the co-workers from the foundation who are here numerously. You can find them with all these people who have this red stripe here, because they take care about everything that is good for you. They organize this conference, and before and after that, they will always be there in order to feel you happy that you are here in Germany. Thanks to them. This location where we are here is a great testimony of the effects resulting from building bridges. Then, when the wall was built around Berlin, bridges came from the US in particular to Berlin and to Germany. We just heard about this. Now, we should remember that it's one of the functions of this reunion to build more and additional bridges. Maybe this time from Germany to the US. I warmly greet the American friends of the Alexander von Humboldt Foundation who are here, and thank you also in particular for your immense contributions to the networking activities in the US. Thanks. Nur einmal im Jahr kommen so viele Humboldtianer zusammen. Das ist jetzt wirklich ein sehr großes Familientreffen, würde ich sagen. Die Jahrestagung ist das größte Treffen von Humboldtianerinnen und Humboldtianern weltweit, und ich heiße Sie noch einmal herzlich willkommen hier. Welcome to Ralph Beste as the representative. No, this thing doesn't like me. As the representative of the German Federal Foreign Office, and also welcome to your team here. It's of a particular honor that you all are here. Welcome, of course, also to the representatives of our other key ministry that supports us very much. Thanks so much for giving us attention and the honor that you are here. Das Humboldt-Netzwerk wäre natürlich völlig undenkbar ohne die Gastgebenden in Deutschland. Es gibt genauso viele Gastgebende wie Humboldtianer. Sie bilden jeweils ein Tandem mit den Geförderten. Neben der eigenen Forschung sind Nachwuchsförderung und Dialog mit Fachkollegen und natürlich mit den Humboldtianern wichtige Tätigkeiten, die sie für uns ausführen. Vielen Dank dafür. But at the annual meeting of the Humboldt Foundation, the Humboldt family comes together, and this is really meant literally. And so I dare to cordially welcome your most significant others in the room. So, jetzt wird's ernst. In der Außenpolitik wird die Wissenschaft gewöhnlich als Soft Power bezeichnet. Ja, ist nicht so wichtig. Habe ich auch schon oft gehört. Aber, liebe Humboldtianerinnen und Humboldtianer, welche Bedeutung der Wissenschaft zukommt, kann man doch daran erkennen, dass sie an viel zu vielen Orten der Welt beschnitten und kontrolliert wird. Die Wissenschaft hat Macht, und sie übt sie über ihre Prinzipien aus. Wäre sie nämlich nur ein belangloser Teilbereich der Gesellschaft, dann würde auch niemand auf die Idee kommen, die Wissenschaft zu beschneiden, die Forschung zu kontrollieren, sie steuern zu wollen oder gar sie zu instrumentalisieren. Also muss es ein Machtfaktor sein. Warum ist das so? Die Wissenschaft hat eine sehr gefährliche Eigenschaft. Sie stellt Fragen. Auch unbequeme Fragen. Wissenschaft stellt in Frage. Wissenschaft zweifelt an. Wissenschaft führt differenzierte Diskurse und verlangt nach einer rationalen Streitkultur. Scholarly activity discloses fake news and alternative realities. And it makes it very difficult to mislead people, even for those who use all the modern means of communication. Peter Strohschneider, der ehemalige Präsident der Deutschen Forschungsgemeinschaft, hat es so formuliert: Forschung nimmt Abstand von ihren Gegenständen, eben um sie erkennen zu können. Sie setzt die Bereitschaft voraus, sich durch die Welt und das, was andere über die Welt wissen, produktiv irritieren zu lassen, mit einer Distanz, die Urteilsvermögen ermöglicht. Zitat Ende. Und dieses Urteilsvermögen darf uns gerade heute in einer vom Populismus aufgeheizten Zeit nicht verloren gehen. Die Wissenschaft hat hier eine ganz besondere, über die eigentlichen Gegenstände ihrer Forschung hinausgehende Bedeutung. Wie wir schon im Grußwort gehört haben, jeder und einzelne von Ihnen kann und wird einen Beitrag dazu leisten, die Welt zu verändern. Da bin ich fest überzeugt davon. neues Wissen zu generieren und es auch weiterzugeben. Aber Wissen in einem einzelnen Kopf alleine hilft nichts. Man muss es nicht nur wissen und verstehen, man muss auch darüber sprechen. Öffentlicher Diskurs, wissenschaftliche Bildung und eine freie Wissenschaft zusammen stellen ein kostbares Gut der Demokratie dar. Und wir brauchen dieses kostbare Gut heute mehr denn je. Das war schlecht. Wie sehr Sie als internationale Gastwissenschaftlerinnen und Wissenschaftler, als Humboldtianerinnen und Humboldtianer in Deutschland geschätzt werden, das zeigt uns der Empfang durch unser Staatsoberhaupt, Bundespräsident Frank-Walter Steinmeier morgen. Das passiert auch nicht jedem, wenn ich das so nebenbei sagen darf. Im Schlossgarten in Bellevue werden Sie morgen empfangen werden und das ist traditionell der Höhepunkt unserer Jahresversammlung. Dieses Jahr ist es nochmal etwas ganz Besonderes, weil es zum letzten Mal für längere Zeit im Schloss Bellevue stattfinden wird, da das Schloss saniert werden muss. Und wir wissen, wir haben gehört, 100 Jahre für eine Dummheit. Also die Sanierung des Schlosses mag so lange dauern, dass Sie vielleicht gar nicht mehr erleben, dass der nächste Empfang dort stattfinden wird. Aber positiv gedacht. Vor uns liegen Tage des Austausches, des Kennenlernens über Ländergrenzen und Disziplinen hinweg. Einige von Ihnen kennen sich schon seit vielen Jahren. Das ist schön, Sie haben zusammengearbeitet und Sie freuen sich auf ein Wiedersehen im Rahmen dieser Jahrestagung. Die persönlichen Begegnungen, die wir in den nächsten Tagen haben werden und auch das Zusammenwirken von echten Menschen und nicht nur Kacheln, das ist sehr wesentlich. Sie werden ein direktes Gegenüber finden, Sie werden Mimik, Gestik, Tonfall, Klang der Stimme, alles das bildet die Basis für wirkliche Begegnung und für Kennenlernen. Die vertrauensvollen Beziehungen zwischen den Mitgliedern der Humboldt-Familie können nur persönlich entstehen. Die elektronischen Medien, die uns möglicherweise manche Reise ersparen, helfen uns dabei, das zu bewahren, aber sie sind keinerlei Ersatz dafür, was Sie und heute hier tun. AVH Research Unites ist das Motto der Jahrestagung und Hashtag AVH Research Unites gives you access to our social media coverage of the event. So if you want to use this, it's easy to find. AVH Research Unites is also a simple description of what the Humboldt Network does. It's not enough to have a network, it also should do something. To unite, oder vereinigen, means according to the Oxford Dictionary, to join together with other people in order to do something as a group. I think this is a pretty good description of what actually the Humboldt Network should achieve. Egal, ob Sie jetzt Humboldt-Forschungsstipendiat sind, ob Sie Preisträger oder Preisträgerin oder Fellow des Klimaschutzstipendiums sind, ob Sie Mathematiker, Theologe, Anthropologe oder Chemiker sind. Sie sind alle hier. Die Humboldt-Stiftung bringt sie zusammen durch die Wissenschaft. Wissenschaft und Forschung vereint die Menschen, weil die Beteiligten ein gemeinsames Ziel haben. Es geht darum, mit einem gewissen Abstand zur Welt sich produktiv irritieren zu lassen und damit einige Zwecke zu erfüllen. Der erste ist Neues entdecken. Ohne Neues keine Wissenschaft. Die Grenzen menschlicher Erkenntnis zu erweitern, die Vergangenheit und die Gegenwart begreifbar zu machen, die Produkte und Diskurse des menschlichen Geistes und Handelns in seiner jeweiligen Zeit zu analysieren und zu reflektieren, den Menschen besser zu verstehen, die Streitkultur zu fördern. Und ich könnte jetzt noch 10 Minuten weiter aufzählen, was man mit Wissenschaft alles tun kann. But our network has an additional dimension of its existence. It brings us together from all over the world to stand in for the freedom of science. And I think this is a very important additional factor. This is what is also meant by this hashtag AVH United. Als Humboldtianer schaffen die Wissenschaft für Sie auch eine besondere Verbindung zu Deutschland. Deutschland ist jetzt nicht so besonders, aber es ist ein immer noch relevantes Land in der Wissenschaft. Aber auf eines können Sie in Deutschland bauen. Das Humboldt-Netzwerk der Stiftung bietet Ihnen eine Gemeinschaft, die einzigartig ist auf der Welt, auf die Sie sich verlassen können. Auf allen Stufen Ihrer Karriere können Sie von diesen Verbindungen und von den Fördermöglichkeiten profitieren und das ein Leben lang. Once an Humboldtian, always an Humboldtian. AVH Research Unites in defending and promoting academic freedom. That was the purpose that I mentioned before. This is the intended additional meaning of our motto. As we heard before, we have entered a period of global disruption. There is not simply a change, this is a massive disruption. Trenches occur all over the world and islands of stability become shaky these days. Some of you know the state of existence from within your local situation, so not everybody has this privilege of living in stable environments, but the Western culture had. And we have to get to grips to this instability that the last time occurred in Central Europe in 1989, and since then it was reasonably stable. Exchange over analysis and consequences about this in itself would be a sufficient reason to come together to this annual reunion. Wir betrachten es als unsere Aufgabe, Internationalisierung als durchlässige Eigenschaft unseres Wissenschaftssystems in unsere Gesellschaft zu begreifen, zu vermitteln und uns dafür einzusetzen. Wir werden jetzt zeigen, wie weit wir damit in Deutschland gehen können, wenn wir den brutalen Angriff auf die Wissenschaft in den USA zusammen mit den etwas subtileren Taten in anderen Systemen nun rasch wirklich etwas Effektives entgegensetzen. Und wir werden etwas entgegensetzen. Sie können dann die Frage stellen, haben wir denn überhaupt irgendeine Kraft, diesem System irgendetwas entgegenzusetzen? Und ich antworte Ihnen, ja, natürlich, wir sind das Netzwerk. Wir haben viele, und wenn viele sich einig sind und sich hinter etwas stellen, dann sind sie stärker als der Widerstand. Und genau das wollen wir jetzt zeigen. Wir werden jetzt 3 Dinge tun. Erstens, Solidarität, Vertrauen und Zuversicht den betroffenen Kollegen und Institutionen vermitteln. Und zwar nicht nur einmal, da ist es einfach, sondern immer wieder und so lange, wie es nötig ist, auch wenn es politisch nicht mehr tagesaktuell ist. Die Kontinuität unserer Unterstützung wird das wesentliche Zeichen sein, an dem man erkennen kann, ob wir das ernst meinen. Das vielfach angegriffene amerikanische Wissenschaftssystem ist das stärkste und beste Wissenschaftssystem auf dieser Welt. Es wird sich sicher verändern, aber es wird niemals zugrunde gehen. Davon können wir fest ausgehen. Zweitens, das Netzwerk stärken und noch mehr Brücken bauen. Das werden wir rasch und wirksam tun und nicht nur darüber reden. Aber wir werden in geeigneten Formaten kommunizieren, warum wir das tun und wie wir das tun. Damit geben wir nämlich Argumente für die Freiheit der Wissenschaft und das hilft auch uns in Europa, by the way. Wir sind nicht nur Guttuer für andere, sondern wir haben ja auch was davon. Und das ist überhaupt nicht verkehrt. Es ist nicht undenkbar am Ende, dass unser freiheitliches und staatsfernes System, das wir heute haben, in näherer Zukunft unter erheblichen Druck kommen könnte. Und dann ist es sehr gut, wenn beide Teile des Netzwerks und beide Pfeiler der Brücke stabil und wehrhaft sind. Heute sehen wir das immer nur in einer Richtung, aber in Bälde könnte sich das ganze Verhalten ja umkehren. Und dann drittens, und jetzt bitte erst recht, wir werden zeigen, zusammen und miteinander, wir werden die Anstrengungen fokussieren und für uns alle sichtbar die Mittel und Wege finden, um den vielfachen Krisen in dieser Gesellschaft und in dieser Welt zu begegnen. Ich möchte jetzt nicht wieder diese berühmte Liste aufzählen, was alles schwierig ist, die kennen wir jetzt schon. Aber dazu sind beileibe nicht nur technisch-wissenschaftliche Lösungen, sondern gleichermaßen wirtschaftliche, soziologische und kulturelle Instrumente und Anstrengungen erforderlich. Also die ganze Palette. Nutzen wir die Interdisziplinarität dieser Veranstaltung und verständigen wir uns auf gemeinsame und wirksame Anstrengungen über alle Grenzen hinweg und fangen wir am besten gleich morgen damit an. If we try to summarize what is needed most now, then it is building bridges. This is what has to be done today, tomorrow, and the day after. Bridges between people, between disciplines, between nations. Dafür braucht es Brückenbauer. Das ist einfach, das sind Sie. Es sind genügend Brückenbauer in diesem Raum. Wir brauchen aber auch Werkzeuge und Material. Werkzeuge haben wir auch. Es sind die Werte der Wissenschaft. Offenheit, Dialogbereitschaft, die Fähigkeit, die Perspektive zu wechseln und die Fähigkeit, auch einzusehen, dass wir Fehler gemacht haben und sie eingestehen können. Damit kann man arbeiten, weil wir alle diese Werkzeuge benutzen. Sowohl die Wissenschaft wie auch die pluralistische Gesellschaft sind auf die kritische Überprüfung ihres Tuns immer angewiesen. Freie Forschung und Wissenschaft und eine pluralistische Demokratie gehören zusammen, ja, sie bedingen einander. Ursula von der Leyen sagte kürzlich, unsere vorrangige Aufgabe besteht erst einmal darin, dafür zu sorgen, dass die Wissenschaft in Europa offen und frei bleibt. Ziemlich gute Feststellung, würde ich sagen. Wir werden viele Brücken brauchen, daher benötigen wir umfangreiches Material. Ich sage das auch ganz deutlich, in unserem Fall heißt das Geld. Wir brauchen finanzielle Unterstützung. Aber Deutschland reiht sich ein in ein starkes Europa und zurzeit arbeiten wir daran, unser Angebot für Forschungsaufenthalte in Deutschland zu vergrößern. Unser Forschungsministerium, das jetzt BMFTR heißt, sagt dazu Folgendes, ich zitiere: Im Angesicht von globalen Spannungen und Verwerfungen im internationalen Wissenschaftssystem setzen wir alles daran, den Forschungs- und Innovationsstandort Deutschland als ein attraktives Ziel für Forschende aus aller Welt auszubauen. Dabei geht es ausdrücklich nicht darum, Personen abzuwerben, es geht nicht um Brain Drain, sondern es geht um Brain Circulation. Ziel ist es, Deutschlands Kooperationsnetzwerke in der Wissenschaft zu intensivieren, um Spitzenforschung auch in herausfordernden Zeiten weiter zu stärken. Wir sollten ihren Nutzen für die Menschen in Deutschland, Europa und der Welt vergrößern und Lösungsbeiträge für eine Welt im Wandel entwickeln. Zitat Ende. Wäre ja schön, wenn es so käme. Die Humboldt-Stiftung arbeitet mit anderen Organisationen der deutschen Wissenschaft gemeinsam daran, diese Erklärung unseres Zuwendungsgebers in eine Aktion umzusetzen. Und diese Aktion muss heuer noch wirksam werden und sie sollte auch die Bedürfnisse der Wissenschaftler auf allen Karrierestufen angemessen adressieren. Ich erwähne hier gerne den Deutschen Akademischen Austauschdienst, die AAD, die Deutsche Forschungsgemeinschaft und die Max-Planck-Gesellschaft als unsere augenblicklich starken Partner. Diese Bemühung wird für die Alexander von Humboldt-Stiftung durch unseren institutionellen Zuwendungsgeber, das Auswärtige Amt, tatkräftig unterstützt. Für die vertrauensvolle Zusammenarbeit mit beiden Häusern, die ich erwähnt habe, und mit vielen, die daran beteiligt sind, möchte ich mich deutlich und ausdrücklich bedanken und ich würde mich freuen, wenn es Ihnen einen Applaus wert wäre. Sie haben mich schon fast überstanden. Aber ich muss noch zwei Sachen sagen. Erstens, wir vergessen nicht, dass es bei Weitem nicht nur unsere Freunde in Amerika sind, die hier betroffen sind. Die Kolleginnen und Kollegen erleben natürlich seit Monaten einen für die Geschichte der USA, würde ich sagen, beispiellosen Kampf gegen die Wissenschaft und die Wissenschaftsfreiheit. Die Trump-Administration setzt auf Chaos, Verwirrung und Einschüchterung, und das machen sie sehr gut. Die offene Wissenschaftsfeindlichkeit und eine zelebrierte Anti-Intellektualität zielen auf die pluralistische Gesellschaft und die Demokratie in Amerika. Sie zielen gut, aber sie werden es nicht erreichen. Die Administration Trump gefährdet auf lange Sicht die Prosperität der eigenen Nation sowie die Leistungsfähigkeit des Wissenschaftssystems. Man kann es noch härter formulieren: Durch die Beschneidungen, die sie in der Klima- und Gesundheitsforschung angesetzt haben, gefährden sie aber auch aktuell Menschenleben. Es ist sehr offensichtlich. Es entsteht nachhaltiger Schaden für den gesamten Globus und auch deswegen, weil ein Teil des, was nicht so oft beachtet wird, global wertvolle Sammlungen von Daten sind unzugänglich oder werden sogar zerstört. Dieser Schaden ist immens und betrifft alle Forschungsnationen der Welt. Dieser Schaden betrifft vor allen Dingen Sie, die jungen Leute, die hier sitzen. Denn die internationale Mobilität der jungen Generation wird wesentlich eingeschränkt dadurch. Der übliche Zyklus, wie Wissenschaft auf der Welt funktioniert, ist unterbrochen. Das ist mit Sicherheit nicht gut. Deshalb gilt unsere Anstrengung den Betroffenen aller Nationen, so wie wir bisher bereits Humboldtianer aus allen Nationen fördern. Niemals hätte unser Namensgeber es verstanden, wenn wir Programme nur für Forschende einer Nation gemacht hätten. In dieser Krise der großen Wissenschaftssysteme vergessen wir nicht, dass wir uns im globalen Süden weiter engagieren müssen. Das ist etwas, was so gerne vergessen wird, aber die fernere Zukunft wird dort mehr stattfinden als in unserer Region. Ich versichere Ihnen deswegen, dass die zusätzlichen Aktivitäten, die wir unternehmen werden, nicht zulasten der Unterstützung des globalen Süden gehen. Wir werden auch nicht die sorgfältigen Auswahl unserer Geförderten und unserer Prinzipien der Chancengerechtigkeit zur Disposition stellen. Egal, was wir tun, Qualität ist Qualität und ist unabhängig von Zeiten. Das darf nicht geschehen. So setzt die Humboldt-Stiftung ihren Anspruch um, als Mittlerorganisation mittels Wissenschaftsdiplomatie nicht nur der Wissenschaft, sondern auch der Politik und damit auch der Gesellschaft zu dienen. Eine zeitgemäße Science Diplomacy benötigt wissenschaftliche Fachkompetenz in der Politik und in der Diplomatie genauso, aber, und das ist vielleicht auch noch wichtiger, noch mehr diplomatische Expertise in der Wissenschaft. Das ist auch eine Zweiwegbeziehung. Mit dem Humboldt Placement Scheme fördert die Humboldt-Stiftung den Austausch zwischen Wissenschaft und Diplomatie und wir sind sehr glücklich, dass wir ankündigen können, dass am 1. November tatsächlich die erste Person ins Auswärtige Amt kommt. Sollten Sie Interesse haben am Humboldt Placement Scheme, wir sind offen für mehr. Wenden Sie sich an mich oder irgendeinen Mitarbeiter mit dem roten Streifen und wir werden dafür sorgen, dass so etwas funktionieren kann. Aber auch jenseits der außenpolitischen Institutionen muss Wissen stärker und besser in die Politik und in die Gesellschaft vermittelt werden. Statt über ein postfaktisches Zeitalter zu klagen, geht es doch vielleicht darum, immer wieder Tatendrang anzufangen und mit Tatendrang und Optimismus in die Vermittlung von Wissen einzusteigen. Immer wieder. Jetzt habe ich viele ernste Worte gebraucht und vielleicht auch nicht die richtigen, aber eigentlich ist ja ein Tag der Freude. Also ein Schlussgedanke. Etwas anderes. Ich wende mich an die Theologen unter Ihnen und Sie werden mir zustimmen. Am spannendsten sind doch diejenigen Dinge zwischen Himmel und Erde, die man nicht wissenschaftlich erklären kann. Wenn man jetzt so genau weiß, was das ist. Man kann sie jetzt nicht erklären, vielleicht nie, weiß man nicht so genau. Wenn sich nämlich Menschen versammeln und sich gemeinsam hinter irgendetwas stellen, zu vielen ein Ziel verfolgen, dann bewegt sich etwas, dann ist Veränderung möglich. Die Humboldt-Community, der Rechner ist der Meinung, ich bin schon fertig. Die Humboldt-Community ist eine Gemeinschaft, durch die vieles möglich werden kann. Sie vereint die Besten aus der globalen Wissenschaft. Sie stiftet Identifikation, Zugehörigkeit und Vertrauen. Diese drei Worte sind the spirit of the Humboldt Association, the spirit of the Humboldt Foundation. Lassen Sie uns diesen Spirit nun nutzen. Jetzt brauchen wir ihn besonders. So I invite you now all, or us all, to expose us to this Humboldt spirit. In some places in Germany you can really find it's coming out of some medieval places. Here is no medieval place, but the Humboldt spirit is also here. You are here. Assemble the network, find partners and friends, and, as I said before, meet our representatives who will take care about you. Hiermit ist jetzt endgültig Schluss. Ich erkläre die Jahrestagung für eröffnet. Bitte, schauen wir nicht zurück und beklagen wir nicht, was wir verloren haben, sondern nehmen wir dieses Familienfest als Anlass, um mit Zuversicht und Tatendrang nach vorne zu gehen. Mit diesen Worten wünsche ich eine tolle Veranstaltung und ich bitte den Nachredner vom Auswärtigen Amt auf die Bühne. Vielen Dank.
Sehr geehrter Herr Professor Schlögl, herzlichen Dank. Danke für die Einladung und danke für die Gelegenheit. Herzlichen Dank auch an alle Mitarbeitenden der Alexander von Humboldt-Stiftung, an den neuen Generalsekretär, an scheidende Abteilungsleiter, Herrn Hesse, an den ehemaligen Präsidenten, Herrn Schwarz. Die sehr gute Zusammenarbeit zwischen Auswärtigem Amt und Humboldt-Stiftung dauert schon sehr lange und sie ist auch weltumspannend. Als Staatsministerin Güler und ich heute Morgen, ich durfte sie begleiten, im Auswärtigen Ausschuss waren, wurden wir als eine der ersten Fragen gefragt, wo uns eigentlich Wissenschaftsfreiheit interessiert, in unseren Schwerpunktregionen oder überall. Und die Antwort war natürlich klar, das ist ein globales Thema für uns beide, für uns das Auswärtige Amt und für die Alexander von Humboldt-Stiftung und das weltumspannende Netzwerk, das Sie dafür unterhalten, ist extrem wichtig. Ich bitte um Entschuldigung, Frau Güler bittet um Entschuldigung, dass sie heute Abend im Bundestag ihren Dienst tun muss und hatte mich deswegen gebeten, dass ich statt ihrer rede. Willkommen in Berlin, willkommen in Deutschland und wir sind sehr froh, dass Sie als Humboldtianer und Ihre Familien, aber natürlich auch die Gastgeberinnen und Gastgeber des Humboldt-Netzwerkes hier zu dieser Jahrestagung gekommen sind. Denn Ihre Arbeit in den 60 Ländern ungefähr, aus denen Sie nach Deutschland kommen, Sie sind es, die das Netz ausmachen, und die Humboldtianer, die haben das Thema Wissenschaftsfreiheit behandelt, symbolisieren die Werte der Wissenschaft. Im Namen der Wissenschaft entstehen durch die Arbeit der Stiftung belastbare und vertrauensvolle Beziehungen zwischen Individuen. Und diese stellen in Wahrheit die Grundlage für feste und respektvolle Beziehungen auch zwischen Gesellschaften und ganzen Nationen dar. Und dieser Geist, in dem Humboldt arbeitet, ist eben für uns auch wichtig. Und ob es um Kontakte nach Argentinien oder nach Laos geht, das Humboldt-Netzwerk, und das ist eben die große Stärke, erstreckt sich in alle Regionen und Kontinente dieser Welt und bietet damit auch jenseits der wissenschaftlichen Arbeit einen Schatz an Kontakten, an Kanälen und Möglichkeiten zum Dialog. Gestatten Sie mir, dass ich gelegentlich auch ins Englische gehe, um ein paar der Botschaften unmittelbar und auch ohne die guten Dienste der App an Sie heranzubringen und unmissverständlich rüberzubringen. We thank the Humboldt Foundation for its work. It makes an indispensable contribution towards the foreign policy of the Federal Republic of Germany, especially in times like these. We are experiencing a period of geopolitical upheaval in which autocratic systems that pose a threat to the liberal, rules-based global order are gaining ground. This often brings with it uncertainty and restrictions, or even threats to life and limb. Germany has a clear stance on this. We are determined to take on more responsibility for our freedom and security. The driving factor in Europe is the threat that Russia poses to our order and the challenge it poses to the NATO alliance that just assembled for its summit in The Hague. In response to the fundamental challenges to our freedom, security and prosperity, we will invest substantially in our freedom. And that is first and foremost, and that's what the issue was at stake in The Hague, our defense capabilities. And I think it's important for you or us to give you an idea of what that means. We want to be able to defend ourselves so that we do not have to defend ourselves. The NATO countries will gradually increase their defense spending to 5% of their GDP, and Germany is playing a leading role in that common effort. And we believe this will not only strengthen Germany, but the whole of Europe. We will also further strengthen our long-term commitment to Ukraine. Alongside the United States and the EU, Germany is already the next biggest supporter of Ukraine over the last 3 years in its defense against an aggressive and brutal Russia. It must not pay off for Germany to continue that war. Und in diesen herausfordernden und unsicheren Zeiten sind eben genau die belastbaren Verbindungen zwischen Individuen für den grenzüberschreitenden Dialog von großer Bedeutung. Bei diesem Dialog zähle ich als Vertreter des Auswärtigen Amts eben besonders auf Sie, auf Ihre Expertise und Ihr Engagement. Und um nochmal den Präsidenten aufzugreifen mit seinen Worten zum Thema Soft Power. Soft Power nehmen nur Leute nicht so wichtig, die wenig von Außenpolitik verstehen. Denn die Anziehungskraft und die Glaubwürdigkeit eines Landes, die Soft Power, bewegt vielleicht viel mehr als die sogenannte Hard Power. In this vein, I would like, in the common understanding that soft power is important, I would like to make you an offer. If you wish, we, as the Foreign Office, as the federal government, consider you Humboldtians, who have a special relationship to Germany, as Germany's, may say, voluntary ambassadors. For a Germany, and from a Germany at the center of Europe, a Europe that stands for freedom, peace and prosperity, from a Germany that is reliable, open-minded and tolerant, and that works in partnership with others to shape positive change, domestically and abroad. And actually, this offer comes from an urgent need that we feel. We think we need to explain Germany better, and we would like your help to explain Germany to the world, because you have first experience with our country, and you're a good reference for us. We need you as the bridge builders that the President Schlögl mentioned between your countries and Germany. Die Wissenschaft ist dabei ein ganz zentraler Baustein, auf dem die Sicherheit, der Freiheit und der Wohlstand unseres Landes gründen. Und deswegen ist es eben in einem sehr, sehr wohlverstandenen Eigeninteresse, dass wir auf die Kraft der Wissenschaft setzen. Und Sicherheit und Freiheit und Wohlstand sind eben die Kerninteressen unseres Landes. Wer Wissenschaften oder Universitäten unter Druck setzt, wer den wissenschaftlichen Austausch behindert, der nimmt der eigenen Gesellschaft eine wichtige Grundlage für den Fortschritt und den zukünftigen Wohlstand. Nur eine unabhängige, freie Wissenschaft kann der Gesellschaft und Wirtschaft dienen, denn Wissenschaft produziert eben diese Grundlagen für den Wohlstand. Ob das bei der Klimakrise ist, bei den Pandemien, die Dinge, die wir täglich diskutieren, ohne wissenschaftliche Erkenntnisse würden wir keine Lösungen finden und die Welt wäre unsicherer. Liebe Humboldtianerinnen und Humboldtianer, wir brauchen Sie deswegen in der Wissenschaft, aber eben auch als Vermittler zwischen Wissenschaft, Gesellschaft und Politik, um für unsere gemeinsamen Werte, um für unsere Freiheit einzustehen. Und Forschende, auch solche, die in ihrer Heimat nicht mehr frei und produktiv arbeiten können, unterstützen wir auch, wenn sie bei uns sein wollen, wenn sie bei uns forschen wollen. Und dazu hat der Präsident die Logik, die dahinter steht, Präsident Schlögl ja alles gesagt. Dazu gehört aber eben auch, und das ist uns wichtig, eine Willkommenskultur, die deutlich macht, Sie sind willkommen und dass Sie auch gut sagen können, andere Forschende sind willkommen in diesem Land. Wie ich gesagt habe, wir sind ein weltoffenes und tolerantes Land, das ist uns wichtig und wir wären froh, wenn Sie diese Botschaft auch teilen würden. Und wir hoffen, dass das gut gegründet ist, weil wir hoffen, dass Sie gute Erfahrungen in Deutschland machen. In dem Sinne wünsche ich Ihnen nicht nur eine gute Jahrestagung, sondern auch weiterhin einen guten Austausch mit Deutschland und würde mich freuen, wenn Sie unser Angebot annehmen, freiwillige Botschafter unseres Landes zu sein. Danke.
Lieber Herr Präsident Ziegler, schön, dass wir hier sein dürfen. Lieber Präsident Robert Schlögl, schön, dass wir zusammenarbeiten dürfen. Lieber Herr Beste, schön, dass Sie uns unterstützen. Dear Humboldtians, Humboldtianos, Humboldtianas, meine sehr verehrten Damen und Herren, ich bin erst kurz im Amt, gerade mal 6 Wochen, habe jetzt schon viele schöne Traditionen der Humboldt-Stiftung kennenlernen dürfen, aber Traditionen schließen ja Innovationen nicht aus. Und in diesem Jahr vergibt die Alexander von Humboldt-Stiftung wiederum die Humboldt-Alumni-Preise und zwar für prämierte Initiativen. Und diese prämierten Initiativen beschreiten neue Wege, um nachhaltige akademische und kulturelle Verbindungen zwischen Deutschland und dem Heimatland der prämierten Humboldtianerinnen und Humboldtianer herzustellen. Die Alumni-Netzwerke in den jeweiligen Ländern und Regionen werden gestärkt. Die Auszeichnung mit dem Humboldt-Alumni-Preis ist mit einem Förderbetrag von bis zu 30.000 € dotiert. This year, once again, we want to award Humboldt alumni initiatives that are breaking new paths in sustainable academic and cultural links between Germany and the successful Humboldtians' own countries. They will reinforce alumni networks in these countries and regions. The Humboldt Alumni Award is endowed with funding up to 30,000 €. Thanks to generous support from the Federal Foreign Office, we are able to recognize 3 networking ideas submitted by Humboldt alumni from Ecuador, India, and the Czech Republic. The winner initiatives embrace major challenges. The awards go to an environmental initiative to restore forests in the tropical Andes and to strengthen the ecosystem in South America, an educational initiative in India and Germany to trigger school and students' enthusiasm for science using classroom experiments, and a networking initiative to promote a critical historical culture of memory in times of populism and fake news. The committed people in this networking initiative show the most important issues of our time. In what kind of world do we want to live together in the future? How can we interest our children in the choice of discovery? And how can we reinforce the critical reflection competence, which we need more urgently than ever, to live together well in these challenging times? Looking at these ideas and the dedication of the Humboldtians honored today fills me with happiness and optimism. And I think happiness and optimism are like key competencies for a Secretary General, like Schlüsselqualifikationen für meinen neuen Job. I hope it stays. Optimism, because researchers and practitioners all over the world are rising to the issues and challenges in society and in the environment. Happiness, because they are all seeking dialogue across generations and promoting young people and junior researchers. Especially, the foundation is honoring Dr. Celine Baez from Ecuador for her initiative, a restoration hub for tropical Andean ecosystems, linking science and practice. Professor Dr. Arnab Bhattacharya from India for the project XCITE, or maybe XIT. It stands for Exploring Science Through Experiment, developing and taking exciting science demonstrations to underserved schools and communities. And the third one, Professor Dr. Katarina Kralova from the Czech Republic for the networking initiative Humboldt MemoNet, International Network of Memory Centers, fostering collaboration, exchange, and mentorship in memory studies. Dear Ms. Baez, Mr. Bhattacharya, Mrs. Kralova, herzlichen Glückwunsch. I would like to congratulate you most warmly on being granted the 2025 Humboldt Alumni Award. Please now join me on the stage. And I also would like to have Festive and Robert Schlögl on the stage for this, to give you the certificates. Yes?
Network of scientists. And so it's a good idea that we also have an excellent piece of science here. I have now the pleasure to introduce our keynote speaker, the Alexander von Humboldt Professor Henning Walczak, who will give us insights in current medical research on therapies for cancer, infectious diseases, and autoimmune diseases. Henning Walczak is a professor of biochemistry at the Center for Biochemistry in the University of Cologne's medical faculty. And since 2013, he's professor of cancer biology at the Center of Cell Death, Cancer Inflammation at UCL Cancer Institute, University College London. Professor Walczak started working on cancer research at an early stage. He completed his doctorate at the University of Bielefeld with a dissertation that he conducted at the German Cancer Research Center in Heidelberg. He returned there as head of research and head of a research group on apoptosis after some time in Seattle. From 2007 to 2012, he held a chair in tumor immunology at Imperial College London before he transferred to University College London, where he is head of the Center for Cell Death, Cancer and Inflammation. Until 2019, moreover, he headed the Department of Cancer Biology and was scientific director of the Cancer Research UK UCL Center. There would have been plenty of opportunities to simply stay there. But the Alexander von Humboldt Professorship, at the time Germany's new most valuable research award, took him to the University of Cologne in 2019. Thanks so much. Whilst you, we all, including me, are sitting here, we are shaking hands, hugging old acquaintances. Our immune system is continuously doing an amazing job. We don't recognize this. It's cleaning up from inside. And this is enormous quantity. Billions of cells in the adult body kill themselves off every day. You will be familiar with this term programmed cell death, known as apoptosis, which is a self-protecting mechanism in nature. Disruptions of this mechanism are thought to be a decisive factor in the development of cancer, autoimmune diseases, and indeed inflammation. The proteins that control these processes are called cytokines. And you may remember that during the COVID pandemic, some patients who were very seriously ill were referred to as having experienced a cytokine storm. We should not come close to this. In such cases, the immune system works overtime. It works very hard all the time. Too many cytokines cause a so-called hyperinflammatory state, chronic inflammation that killed many patients at a time. Professor Walczak pursues this practice from the bench to the bedside. So it's one thing to understand these things on a biological scale, it's another thing to identify this in in the patient that lies in front of you. The results of lab experiments should be transferred to therapy as soon as possible to benefit real patients. So, is it then possible to use the cytokines that can dock onto cells and control cell death in the fight against infectious diseases? Or potentially also for therapeutic approaches to cancer? These are very interesting questions. I think we all of it must be interested in this. We might all have to experience these kind of treatments. And so I'm looking very much forward to hear from Professor Walczak where's the stage of affairs. The stage is yours. Thanks so much.
Thank you very much for this kind introduction. There should have been, I find the machine here, but what I don't see is the talk here. I'd be happy to see my first slide. Great, that is incredibly helpful. Okay, thank you very much. And this is a building in Cologne that some of you may know. It's the Dome of Cologne here, so the pointer works, if you had seen the pointer there as well. So, Cologne. So I'm going to talk about what is presented here on the slide, and I would like to thank the Alexander von Humboldt Foundation for giving me the opportunity to speak here today. But before I come to the topic of today's talk, I need to mention that as I learned today over lunch, that my predecessor, Professor Wilhelm Stoffel, a giant of biochemistry and a giant of biochemical research, not only in Germany but worldwide, has died in the night of Monday to Tuesday this week at the age of 97 years. Professor Wilhelm Stoffel, when I met with him because he maintained an active lab of more than 30 years after his retirement at the University of Cologne, at the institute where I started working on the third floor, and once we had a conversation, and he told me about his time as a postdoc, which he started as the first German postdoc in 1953 at Rockefeller University. And who has ever been to Rockefeller University will know that many of the people who teach there and who do research there are Jewish. And as it happened, they opened their arms for him and welcomed him in the most Humboldtian way. And I'm still touched by that, and he was touched by it when he told me that. And now, a little bit later in his career, in 1992, there was a connection between Wilhelm Stoffel and the Alexander von Humboldt Foundation because he received the Max Planck Prize of the Humboldt Foundation together with Günter Blobel for work they did in collaboration, work that in extensio then led to Günter Blobel in 1999 being awarded the Nobel Prize. That I think speaks for itself, for the quality of the work of Wilhelm Stoffel and the quality of the human being I got to know when I met all the people that used to work with Wilhelm Stoffel when he was still active, and I did not find a single person who spoke badly of him. I do have to exclude the medical students where he took exams. He examined them very harshly, and apparently some of them are still active at the University of Cologne, and it was nice of him to tell me who I'm dealing with there. Anyway, we will celebrate also his life's work today, but I will now switch gears and come to the research that we do. And as Professor Schlögl just mentioned, cell death is essential for the development and maintenance of a healthy organism. It happens throughout our lifetime. It happens during embryonic development. It helps shape our bodies. It helps shape our immune system by selecting only the ones that can react against something that is non-self. It helps in fighting infections. It helps in wound healing, and also the regression of the breast tissue after weaning. And this is just the altruistic cell suicide, also already mentioned by Professor Schlögl. Programmed cell death, the first form of programmed cell death identified was apoptosis. the Greek people in the room will know what it stands for. Apoptosis is the Greek word, if I'm not mistaken, for the natural process of leaves falling from a tree in autumn. So I think it's a very nice way of coining this mechanism. And here, Kerr, Wiley, and Curry did so in 1972 when they saw that it's an ordered process with all these different things happening one after the other. And it also plays a role, like I said, during embryonic development, and I love this picture because it illustrates so beautifully how it does play a role in the sculpting of the mouse paw in this case, but we can also see it. And I think Mike Phelps didn't have that process ongoing because he was very fast in swimming. But so these cells here are all undergoing apoptosis, and one day later, during embryonic development, it looks like this. So apoptotic cell death is really important for development of the body in mice and in humans, and in many other species as well. So it is not always good for you to have apoptosis. There are many diseases where apoptosis does not occur normally. There are diseases where there's too much apoptosis. They are named here. And of course, there's cancer, when there's too little apoptosis. And of course, we want to understand the biochemical pathway of apoptosis so that we can interfere therapeutically and act in a way to make it be normal again. And here is an illustration of the first drug that came out of our understanding of the apoptotic pathways. When I say our, I mean the worldwide, the global community, and really the work at the Walter and Eliza Hall Institute in Melbourne was key to that. Led over many centuries by Andreas Strasser, but many others at the Walter and Eliza Hall Institute. I always say Andreas is in his 35th year of a postdoc because he still looks like a postdoc when you see him, and he acts like a postdoc, just that he knows a lot more. Anyway, so we're targeting cell death in cancer, and it's one way of addressing cancer and treating cancer effectively. We are interested in my laboratory in the so-called death receptor pathways. Those are receptors that can be cross-linked by so-called death ligands. And the first death ligand to be identified is tumor necrosis factor, TNF. And the second one was the APO1 ligand, also known as FAST ligand and CD95 ligand. However, unfortunately, both of these could not be used systemically for treatment of cancer patients because of a lethal toxicity, which in both cases we now know was because it killed normal human cells and not only the cancer cells. So that unfortunately didn't go further, but while doing this research, and I did this research during my PhD, which I did at the German Cancer Research Center in the laboratory of Peter Kramer, but in collaboration with Jens Stein, my former colleague and now friend Jens Stein. And we constructed these proteins before the ligand, before we had cloned the ligand, with which we could block the ligand. And a receptor Fc protein, which is like a decoy for the ligand. We can basically block the ligand when it tries to fly in. It's like, the physicists will know what I mean in terms of when you try to prevent a rocket from coming in as a killer. And pretty much this is exactly how these molecules work. They scavenge away the killer protein, FAST ligand, APO1 ligand in this case. And we showed during that time that the process how a T cell dies upon activation when it has to end, its job, is via the FAST ligand system, as I will refer to it in this talk. And we could show this because we had made this decoy blocker, the blocker of FAST ligand with the extracellular domain of the receptor fused to an Fc part of an antibody. And I did my postdoctoral work at a company called Immunex in Seattle, and they had at the time developed a molecule that looked pretty much the same as the Fas-Fc protein that I explained to you, which had the extracellular domain of TNF receptor 2 fused to an Fc domain of human IgG1. And this became one of the most successful drugs of the last 3 centuries on the planet. Together with other TNF inhibitors, with a turnover of more than 500 billion over the past 25 or 30 years. So these drugs can be also successful as medicines. And we therefore, when I returned, Peter Kramer and myself, we founded the company Apogenics, and we aimed to develop this molecule. And currently, this molecule we think that the best uses will be to combine it with immune checkpoint blockade, because many tumor cells or cells in the tumor microenvironment actually express Fas ligand. And what is better for a tumor than to kill the attacking T cell? And with our drug, we can prevent that. So that's the aim that we want to follow up on there. Now, after these 2 molecules really failed in bringing forward a cancer treatment, TRAIL was discovered, and I just mentioned that it was discovered by Steve Wiley, and this paper was a paper from Immunex the month before I started. So I immediately said, okay, I now want to test whether we can achieve with this molecule what we couldn't achieve with TNF and Fas ligand. So I made recombinant TRAIL, I made recombinant mouse and human TRAIL, and what we found is that can induce apoptosis in more than about 50% of all tumor cell lines, but most importantly, it did not induce cell death in any essential normal cell type, which meant we could use it systemically in vivo, which we then did. And this is just the process of apoptosis. I just want to share this with you, the beauty of the process. You can see how now, after we add a TRAIL to the cells, the apoptotic process begins, the membrane blabbing. You see the cell looks like it's cooking, and at some point, the cooking results in the explosion, and the cell membrane pops open, the cell is dead. Red means dead in this case, and after just a couple of hours, TRAIL has been able to kill all these cancer cells by apoptosis, and this is the process that we intend to bring to the clinic. And in this seminal work, which we then did, we were able to show that treatment with TRAIL can indeed prevent cancer growth in an animal model. This was the first animal model. And over the years, then, we worked on identifying the pathway, and this is really not the audience where I would like to go into detail with the entire process, but suffice to say that we understood the molecular pieces of this pathway in a lot of molecular detail. And what we also learned in the course was that chemo and radiotherapy work via the so-called mitochondrial pathway, or as I just learned on a recent trip to China from my friend Andreas Strasser, who I already mentioned, the Bax and Buck-induced pathway, which is the pathway that used to be known as the mitochondrial pathway of apoptosis. What happens is that chemo and radiotherapy work by inducing that pathway of apoptosis. However, when you have high expression of anti-apoptotic members of the so-called BCL2 family, BCL2 stands for B-cell leukemia 2 molecule. MCL1, for example, stands for mantle cell lymphoma. So you already get the idea that these molecules are highly expressed in different types of cancer. And then these cancer cells cannot die. They're resistant to chemo and radiotherapy. So our research, and with that I mean the research by many people around the globe, again working on this pathway, has led to the fact that we can now attack this from different angles. In fact, our work on TRAIL was part of that. But then work on BH3 mimetics and the drug that I mentioned coming out of the WEHI in collaboration with AbbVie and other companies. This is the BH3 mimetic, and it stands here like this little thing, but this is really revolutionized the treatment of lymphoma and leukemia over the past decade or so since its first approval, and this revolution is not over yet. And SMAC mimetics, I think, are very promising in certain indications. And yet I would like to focus for the next couple of minutes on another targeted medicine that we found that nicely collaborates, synergizes with trail in killing cancer cells. So I told you that not all cancer cells are created equal, that some of them are actually resistant to trail, but when we take a CDK9 inhibitor together with trail, they are totally wiped out. We can fully kill these cancer cells. And this doesn't only work in vitro in a cell line, but it also works in mice, as you can see here. If we look at the cancer cells, and the cancer cells are here marked with a luciferase, and so we don't have to kill the mouse. We can look at the tumor cells as they grow in vivo because the light emits, and we can see it at least in white mice, but not in black 6 mice. You can see it through the skin. You can see how the tumor cells are controlled to a certain extent by trail, not by CDK9 inhibitor at all, but we can completely obliterate cancer cell survival by the combination of trail with CDK9 inhibition. So that's something that we think is very highly effective, and we want to take this to the clinic next. But the question then was, of course, okay, it's great that we can do that, but does it extend beyond these different types of cancer cells? And it does work across the board. We can see that it works in many different cancer cells. The red curves means these cancer cells are dead with a combination, whereas the black curves are the trail only. So really an incredibly high synergistic effect that we see. Now, that means we can overcome trail resistance of cancer cells very broadly, but the problem in the clinic is not trail resistance because we don't have trail in the clinic yet. The problem is chemotherapy and targeted therapy resistance. So what we did here is an experiment that we did here because Dagmar Kulms from Dresden was so nice as to share her cell line panels with us. She had established cell lines, melanoma cell lines that were resistant to dabrafenib, trametinib, and cisplatinum, and we compared the sensitive and the resistant ones. And in both cases, as you can see between the blue and the red curves, in both cases, whether the cells were sensitive or resistant, the cells maintained the same sensitivity to the trail and CDK9I combination, meaning that I think with this combination, we can pretty much broadly overcome chemo and targeted therapy resistance in addition to trail resistance. So I think this could mean that we can take this concept, which we summarized here already in a review a few years ago, into the clinic, and that's actually the next step that we want to transfer that concept into the clinic. Now I want to switch gears. Sorry, I was a bit too quick, because really I want to come to cell death and inflammation in cancer, because cell death is one principle, but tumor-promoting inflammation is another. And in order to understand tumor-promoting inflammation, it's clear that the one thing you need to understand is TNF signaling. As Fran Borkwell, a colleague from London, very beautifully illustrated in this review she wrote a few years ago. And here you can see that TNF is really crucial for this, and TNF signaling wasn't, understood to the level that we thought it should be understood. So we applied the same methodology we used to study the trail and the FAS signaling pathways. We then applied to the TNF signaling pathway, and lo and behold, we identified a new player in this pathway. This one here, LUBAC. HOL1, HOLP, and CHARPIN together form the so-called linear ubiquitin chain assembly complex, and with the presence of LUBAC, we could then identify how this beautiful molecular machine actually really works, and how the activation of gene expression involves also the activity of LUBAC, placing linear chains or methionine one-linked ubiquitin chains in the complex. I only want to say that this component has become instrumental and has been identified now as a crucial component in virtually all immune receptor signaling complexes, not only in the TNF receptor complex. That's where we found it first, but it now forms a part in many signaling complexes. As it always happens, many times happens with an initial discovery, it then it can be shown that the same principle applies to many different systems. And normally, this complex can transition to this complex 2 that can induce cell death, both apoptotic cell death, but also another form of programmed cell death known as necroptosis. But this normally is prevented by, by also the activation of these genes here and by the action of Lubach in the complex. So this complex is important and prevents this cell death induction in many situations. And we then learned a lot of different things about the Lubach complex, which makes these linear ubiquitin chains. And I don't want to go into details, but there are different types of linear of ubiquitin chains. And if I just used my two fists here to illustrate that for a second, so let's say a linear chain looks like this, and a so-called lysine 48 chain looks like this. You can think that there could be molecules, other proteins that can bind to this structure across the two ubiquitins, or to this structure specifically. And that's how the different chain types create specificity in the ubiquitin system. And thereby, you can recruit different adapter proteins that then exert different functions. And that's how these different chain types work. Okay. Just want to mention that. And then when Lubach is absent, what we found, then you get this a lot more transition to complex 2, and therefore a lot more cell death, which can be apoptotic or necroptotic in nature. But what is clear is when Lubach is absent, there's a lot more cell death, and we found different pathophysiological consequences of that, because one of the Lubach components is sharpin. And mice with a mutation in sharpin get an inflammatory skin disease. Now, what I didn't mention to you is that this arm of TNF receptor signaling was referred to as the inflammatory arm of TNF signaling up until we made this discovery. And what was always neglected was this TNF-induced cell death. This was the important arm. People tried to block many different steps here to block TNF-induced inflammation, and nothing worked. And it was clear something else must happen, and therefore we then checked what happens when we in these sharpin mutated mice, and what we found is when we take away TNF, then these mice actually don't have an inflammation anymore. So the inflammation is TNF driven, but what led us to believe that this was TNF-induced cell death driven was the fact that the only thing that was increased in cells devoid of sharpin was TNF-induced cell death, whereas TNF-induced gene activation was actually reduced. So we asked the question, what if cell death could be the cause of this disease? And in fact, that was the case. So TNF-induced cell death is the trigger for chronic skin inflammation, as we then confirmed in these two studies. We already deduced this from our data in this first study mentioned here. So what this means is we discovered that as a new cause, a new etiology for TNF-mediated chronic inflammatory and autoimmune diseases, like, for example, rheumatoid arthritis, Crohn's disease, psoriasis, which can be treated with TNF inhibition, but not in all cases it's successful. And for example, multiple sclerosis doesn't react to TNF inhibition at all. Or, put more simply, it's the cell death stupid, right? So it's rather than the gene activation, that too much TNF-induced gene activation causing the inflammatory disease, it's too much TNF-induced cell death that causes the disease. Now, we studied the Lubach function in a lot of depth. We made sharpin deficient mice, HOI-P deficient mice, and HOI-1 deficient mice. And I will not go into detail into this beautiful work that Nieves Pelzer did here and published in Nature and Cell Reports, but instead I wanted to focus on work that Lucia Taraborelli in the lab did together with Nieves Pelzer. And that's Lubach and skin inflammation, because is TNF the only cell death mechanism that can induce an untoward inflammation? So we crossed mice that are, mice so that we could make a Lubac deficient mouse in the skin by crossing the two other components, HOI-P and HOI-1, and knocking out these components specifically in the skin. And what we can then say is that, and we checked, and these mice get already at birth an inflammatory disease, so a lot earlier than the sharpen deficient mice, which is understandable because HOI-P and HOI-1 are both essential components of Lubac, whereas sharpen is not completely essential. But here what you can see is that if we take away TNF receptor 1, after a few days, these embryos, or these little, not embryos anymore, of course, these newborn mice out at day 4 look completely normal. However, at day 70, they develop a very nasty skin inflammation, exactly like the one in the sharpen deficient mice. But of course, it cannot be mediated by TNF-induced cell death anymore, because TNF in the TNF receptor knockout mice, TNF cannot kill any cell. And clearly, the inflammation also looked very much the same as in the sharpen deficient mice. So TNF receptor 1 deficiency delayed but did not prevent the aberrant cell death and the skin inflammation. And here you can see that just the cell death data on that. So the question was, what drives dermatitis in these HOI-P and HOI-1 echo mice, meaning epithelial knockout mice? What is the driver of this inflammation? And what drives the dermatitis in HOI-1 and HOI-P echo mice in the absence of TNF receptor 1? And in order to address that, first we wanted to see, okay, could it be cell death? We removed caspase 8 and RIP3, two downstream mediators of apoptotic and necroptotic cell death. And what we got is that the mice had no phenotype anymore. So clearly, the answer to the first question is it was cell death. Stupid, right? And the same holds true in the other mouse where we knocked out not HOI-1 but HOI-P in the skin. So this is just more scientific than important in this context. So the answer is it's cell death, stupid. Aberrantly increased TNF-induced cell death was responsible. And the answer to the second question, of course, is the same. Aberrantly increased cell death was again the culprit. But if TNF receptor signaling couldn't happen, another question that emerged from that, of course, was what triggers this aberrant cell death in the absence of TNF receptor 1? And here we are in one of the favorite German pastimes, Krimi, Sunday evening, Tatort. Who is the killer? Yeah, when it's not TNF. And we answered that question in this way. We looked at it genetically. We knew by the time I said this, Lubac is involved in many different immune signaling systems, not only TNF, but TRAIL, Fast ligand, other TNF superfamily members, you name it. But also LPS can trigger by TLR4, and TLR3 and other death ligands and other immune receptors can trigger it. So we went after it genetically, and we thought TRAIL could be a reason, could be one, FAST CD95 could be one, TLR3 could be one. So we combined the knockout of TRAIL receptor with that of TNF receptor, no change. We combined the knockout of CD95 FAST with that of TNF, no change. If anything, they got worse. The knockout of TLR3 together with TNF receptor 1, no change. So at this point, you have to be really convincing to your postdocs and PhD students if you want to ask them to do a quadruple knockout mouse. If anybody has ever done that, it's not very easy, and the people were, Lucia and Nieves were not very happy, but I went to my knees and I basically pledged with them. I said, look, please do this one last back cross. When you combine the knockout of TNF receptor, TRAIL Center. So yeah, traveling the world, but then coming back to London and then taking the family. This is in July 2019 when we still lived in our beautiful little house in Chiswick. Then we got on the ferry from Dover to Calais on the 31st of July, in fact. And this is just a picture here with my wife, Eva, and Emilia, my daughter. And here's again Emilia, Maximilian, and Hannah in the picture, already in Cologne having an ice cream there. So we made the transition, and then of course I go back to my traveling duties. Sometimes go to London, I go to Sao Paulo, Guarujá on the beach, Taipei, then I go to Madrid and Zaragoza, and this will come important in a second, but I also go to Sochi, at the time it was still possible, and then to Obergurgl, and then I was really exhausted, had to sit outside after skiing, went to the sauna, and then some people took a picture of me, and that was it, and that was in January 2020, and then of course we heard these news coming out of China, and by April 2020, COVID-19 had become pandemic. And you can see here, we could see it coming towards us already in January, February. But by April, these were the figures, and this is what happened during that time. Now, this is the data as of a couple of weeks ago today. 7.1 million deaths. 670 million cases, I think that's a bit an underestimation considering the number of people on this planet. I would hardly believe that only 10% of people were infected by SARS-CoV-2. So I bet this is a bit an underestimation. Is this the first pandemic? No, it's not. Spanish flu. Flu is caused by influenza virus. And there are always different influenza viruses that come along and get to us. And this one was particularly deadly. It was only called the Spanish flu because in certain parts of the world, because of the war raging only in Spain there was free press, and of course it was first reported in Spain, yet all the war-embraced countries also had the Spanish flu. And 50 to 100 million people, if not more, died because of an infection with the Spanish flu. And the disease is really very similar to COVID-19 today. And of course, I would also like to mention this HIV pandemic ongoing since 1981, which has already killed 34 million plus. And it's often forgotten, but it shouldn't be. And if you look at the recent history of pandemics, epidemics, and virus outbreaks, you will see SARS-CoV-1, as we now know it, had a case fatality rate of 10%. That means 10% of people who got infected died. MERS coronavirus, a case fatality rate of 34%. That's every third person who was infected with MERS coronavirus died. With SARS-CoV-2, we think the case fatality rate, depending on when you look and at which time, was between 0.7 and 4.5% about. Throughout the world, and so the case fatality rate looks lower, but the virus was just more contagious, more infectious, so it was easier to catch it. This inspired a work that I will really cover in the last 3 or 4 minutes, but I need to mention that this was done in collaboration with Julián Pardo, who I had just visited in Zaragoza, and Maria Pilar Ruiz Seco, who works in Madrid, so a very good reason to travel, also to my family and my lab at home, please remember that. But Julián Pardo was my collaboration partner in this, and is still my collaboration partner with his wonderful lab members, Irache, Michael, and also Diego, who used to be in my lab and then went to Zaragoza to then work there, and then we were in contact, and he said, yeah, the hospitals here in Zaragoza are full of people with COVID, and then we said, okay, we have an idea for a clinical trial, so let's do this together, and my friend Michael Bergman from Vienna, who is an expert in influenza research, we teamed up, and we teamed up also then with Thomas Höger at Apogenics, because we thought, okay, this is, we need to use the drug that we had developed. Because as it turns out, SARS-CoV-2 really is a lethal disease because it induces acute respiratory distress syndrome, and therefore to reduce the mortality, we have to understand how the infection triggers severe COVID and develop, based on that newly gained understanding, novel therapies. So what can we add? Well, I just told you that fast ligand can induce a lethal inflammation in the skin. But what if the same principle is true in the lungs of SARS-CoV-2 infected individuals who have severe COVID-19? So we then made mice which are adapted, so made a mouse-adapted SARS-CoV-2 virus. And we used this in vivo model. And here you can see when we infect mice, these are young bulb C mice or 8 months old black 6 mice. In both cases, these mice die. And now let's treat them with our inhibitor, and treatment 2 days after infection when the mice are already very ill. We treated them, and the mice now have a significant decrease in disease severity and also lethality upon MA20 infection. So, and it goes in line that fast ligand inhibition by the molecule decreased cell death and as a consequence also inflammation in the lungs of these mice, which led to the survival of these mice. That's great, we can cure COVID in mice, but what about humans? So we then, that's what I mentioned, we teamed up with Thomas Höger, and then we had a meeting with the investors of Apogenics, and I would like to mention here that this clinical trial would not have been possible without the support by Dietmar Hopp, the founder of SAP, who was also the investor into Apogenics. And I also personally thank him for this possibility that he gave to us to do this clinical trial at the time. And we called it the clinical trial Assunctis for Asunarset in Spain because we contacted our friends there. And this is just a clinical trial protocol. We compared standard of care, what everybody gets when they get severe COVID. Severe COVID means you're in hospital and you need oxygen, otherwise you would die, okay? And you either get the standard of care or you get Asunarset at 3 different dose levels, 25 milligrams per week, 100 or 400 milligrams per week. So we did that study, and we had the first patient in October 2020. I thought this was really slow because in April we submitted the protocol, but of course it's not an approved drug, so it took a bit longer than with some other inhibitors, but there you have it. The last patient in was in September 2021, and then the data was ready in Q3 of 2022, and then we wanted to get the data out, and the company that was controlling the data at the time was a company in the second country where we did Assunctis, which was Russia. And just a couple of weeks earlier, Russia had invaded Ukraine, so that delayed, unfortunately, us getting the data. But here's the data. The data is 3 different arms. We have strong trends for efficacy, closely missing statistical significance in all 3 arms. But you can see in all 3 arms, 9, 8 days versus 13 days. This is until the people get better. Okay, and so we can combine these arms. And when we do that, we have clearly statistically significant data. People get out of hospital after 8 days instead of 13 days. And this is clearly statistically significant. And what is more, in my view, even though the numbers weren't there to make this statistically significant, but what you can see here is the mortality rate in the 2 groups that received 100 or 400 milligrams per week was reduced by 20%. So imagine we would have had a drug during the pandemic where people would have got out of hospital on average after 8 days instead of 13 days, and a drug that would have reduced mortality by 20%. I just showed you the numbers. You make the calculations yourself. So I think we have identified an efficacious treatment for SARS-CoV-2 in mice and, importantly, also in humans. And I think it's safe and efficacious treatment for patients with severe COVID-19 through inhibition of fast ligand. So who cares? COVID is over, isn't it? Well, not really. Well, not really. We still have COVID-19, so SARS-CoV-2 variants circulating. And just because we have these numbers for the United States, because these government places have not been shut down yet, the CDC, I know it's under threat as well, but they have reported a total of more than 15,000 deaths, COVID confirmed COVID-19 deaths over the last 6 months. I don't know whether you remember how many people died on 9/11, 2001. It was about 3,000 people. We have a 9/11 every other month, if not more, in the US right now. And it's just simply ignored. And we have a lot more throughout the world, simply ignored because we want it to be over, right? Now, apart from that COVID-19, I also mentioned that a very similar process is at play in influenza. And here you can see how the levels of Fas ligand, the target of our drug, is highly increased in the lungs of people who are severely ill and treated in the ICU, in the intensive care units in the hospitals. You do a bronchoalveolar lavage in these patients, and you can then measure the molecules, the cytokines in these in there, and Fas ligand is one of these cytokines. But it's also up in influenza virus infected individuals. So the same principle likely also works in influenza patients. So I think we have a new treatment not only for SARS-CoV-2, for COVID-19, but also for severe flu. And what about severe flu? Recent history of influenza, and this is not including the 1918-19 pandemic, but of course this is still very, very high in the US, but also in Germany. There are many deaths from this all the time. There's a huge burden on the health system every year, and we never know what will be coming in the future. To summarize, we have shown that we have a treatment with which we can get to faster improvement, but also a reduction in mortality in mice and also in patients with severe COVID-19, thanks to Fas ligand blockade. And of course, it would be good if we could use it in a broad, if we could check whether it's broader applicable, like for example in influenza cases. That would be, of course, fantastic if we could also treat there. So what are the potential benefits? We reduce mortality and disease burden. The duration of the hospital stay goes down. The hospitalization rates go down. The cost per patient goes down because even if the drug costs money, I mean, if you know how much it costs to keep a patient in an intensive care unit for a day, you know what I'm talking about. And for me, also very important, and in the theme of what we're here today, societal disruption could have been reduced. We could have, if we had had this drug at the beginning of the pandemic, we could have had a lot less disruption to our societies. And with that, I would finally like to thank my team, my collaborators, you for your extended attention, and also the Alexander von Humboldt Foundation, because without the Alexander von Humboldt Foundation, and Stefan Mehlich will know exactly what I mean, I wouldn't have been able to do this additional research that came up when COVID came up, and explained it to Dr. Mehlich, and then the Alexander von Humboldt Foundation really supported us a lot to do all this preclinical work. Without Alex and his foundation and the members at the foundation working for all of us, the scientists, this would not have been possible. And with that, I would like to, again, thank you for your attention.
I think in the name of the whole audience, I would like to thank you very much indeed. Stay here, don't run away. Why I want to thank you, because you showed so brilliantly how deep understanding of molecular mechanisms can really transfer into things that are important for society. This doesn't happen so often that a single person can bring this all the way from understanding a biomedical correlation into something that has really evidence and relevance for the society. Thanks so much indeed to show this to us, to indicate this to us, and as a short appreciation, I give you a little book. Thanks so much. Es war ganz toll. Vielen Dank.
Thank you.
Now we leave.
Yeah. Thank you. I do want to mention it wasn't a single person. This was always a team effort, and it wouldn't have been possible without the team, without the funders, and the people behind this. So thank you very much.
So the next topic will be Humboldt dialogues. We have many people with interesting stories, and I think we could talk days about the Humboldt dialogue. I want to present 2 examples for Humboldt project for Humboldt stipends. Dr. Elisa Cristina Macalo Bras from Coimbra, Portugal, and Dr. Bronwyn Winch from Melbourne, Australia. Please come to me to the stage. We start with the presentation of the content of the topic of your research, and we begin with Elisa. Maybe you noticed that I come from Bavaria and Portugal. Well, we have some things in common. More or less 10 million people. We are quite proud of our country, and not many people understand our language. Você pode começar com a vossa apresentação, por favor.
Obrigada. First of all, good evening, everyone. My presentation. Well, it's here. Good evening, everyone. First of all, I would like to thank the Humboldt Foundation for this excellent opportunity to be here today and to present my research work. I'm a chemist, and as a curious chemist, I am deeply fascinated by fundamental questions, and I am always very curious about the beautiful things that surround us. And so this fascination, it brought me here and led me to this project about the formation of organic molecules under extreme conditions in space. Oh, sorry. Okay, some of these molecules that have been found in space, including amino acids, carboxylic acids, amides, and sugar-related molecules, they have been unexpectedly detected there. And this, of course, has raised a lot of questions. And what is extremely intriguing is how the same molecules that are present in living systems and can be prepared in conventional chemistry laboratories can also be found in the interstellar medium. So this means, and this slide is an analogy to what happens. We have different paths, different conditions. One of them are controlled, and the other are extreme conditions of temperature, radiation doses, and so on, but they bring us to the same end. And what is unexplored is how do these complex molecules form under such extreme conditions of low temperatures, low pressure, high radiation doses, high dilution from very small building blocks, such as water, carbon dioxide, carbon monoxide, ammonia. And sorry, this is not easy. Well, I think there's a slide missing, but I can try to explain you. To try to mimic these conditions, I have assembled one high radiation source to our cryo chamber in our laboratory to mimic the conditions, the low temperature, the low pressure, and the high radiation doses. And this has been prepared in collaboration with our workshops. And the aim is also to address this question: how do these complex organic molecules are formed in such conditions? And the aim is to explore new reactivity paradigms and give answers to the question. don't know what happens here. With all being said, and I hope I could clarify the project here, I just want to express my deepest gratitude to the Alexander von Humboldt Foundation for the funding, of course, Professor Peter Schreiner, and the host institution for the warm welcome, and all the group members, and also thank you for your kind of attention.
Thank you.
So please, hand over, thank you. So next presentation, Bronwyn, you heard about that Kant was traveling 15 kilometers, I am about 500. I don't know how many thousand kilometers you have behind you. Please start your presentation of your research.
Lucky last speaker, so I will try and keep it brief for everyone. I'm going in a very different direction. There we go. My research is an extension of my So my research is in the area of peace and conflict studies, focusing on the community level. And the site that I work in is in Mindanao in the southern Philippines. And so for a bit of context, the kind of 4 connecting bits of information there for you are that it is the world's longest running communist insurgency. There has been, since Spanish occupation, a rebellion, a separatist movement. So there is now an autonomous region in Mindanao. And then we have extreme natural resource exploitation because Mindanao is very resource rich. And then since American annexation, there has been increasing, well, since before that, but a very vulnerable, very marginalized indigenous population in Mindanao, and who are disproportionately affected by the armed conflict. So that is the focus of my research, and it's an extension of the work that I was doing in Timor-Leste, sorry, near Indonesia. The basic idea is that peace-building work, humanitarian interventions is very top-down, usually, and the focus here is to be bottom-up. The fundamental kind of concept is worldviews, life worlds, that the way that a person is, their way of being in the world, their way of seeing in the world, navigating it, it's different for everyone. So just think context, situatedness. And so while fundamental conditions of human life, safety, fear, threat, these are universal, the way that they can be constituted differently across different societies, different cultures, different religions, cosmologies, means that there can't be a cookie-cutter approach. I'll just skip ahead. So the way that I've been approaching this project through my fellowship is that I have 2 research partnerships, one practitioner-based, the other one an academic partnership. And so Belay Mindanao Foundation is a peace-building organization that works on the ground, and they basically, I do whatever research that they want me to do, which is the action-oriented stuff to complement their programs. Mindanao State University, this is kind of about knowledge transfer, building up knowledge exchange, and knowledge production between what we call the global south and the global north, whether you want to use those terms or not. So my research is slow burn, and I mean really slow burn. Even this 4 trips of 6 weeks is less for me. And so I can't say that my project is as scientifically rigorous as the other research we've been listening to today. Some of my best research has been done in my pajamas having breakfast with neighbours. So it's really very, very organic-based methodology. It's just about spending time with people and building relationships. Storytelling as a methodology. Like I said, slow burn. So for me in Mindanao, it's going to take me a long time to build the relationships that I need to build in order to do the work that I do. And it's not only because of the reasons I mentioned before about a very marginalized community, they're geographically isolated, but coordinating with the military and local government to get into certain areas is extremely difficult. So let's see what happens in the next 2 years. Thank you.
Thank you. So thank you. Thank you for the inspiring presentations. Now we have some time left for personal questions. This year's motto of the annual meeting is Research Unites. Elisa, could you tell us about your experience uniting researchers globally?
Well, I believe that research is inherently touches the collaborative process. I think it's very difficult to do research work alone in solitude. And luckily, I've been inserted in very collaborative environments with people from different backgrounds, with different perspectives, and we always help each other in finding solutions. And that's my experience, and of course the topic that I've shown, it intersects several areas, not only chemistry but also physics, engineering, and we scientists, we work together because this topic will overlap, this research will overlap other research work, and together we can solve difficult problems.
Thank you. And what has been the most rewarding aspect of your research fellowship so far? Most rewarding.
Most rewarding. So I've started this Humboldt Fellowship in December, and I already have very nice results after the assembly of these equipment. And it was a challenging process. I had to counter several problems that I have found along the path, and it was slightly out of the box research. And so some senior researchers that worked in that lab didn't believe that it might work, but it actually works. So it also shows that we should be resilient and we should believe in our own ideas and fight for them.
Okay, and now the last question to you. What do you enjoy most about living in Germany, professionally and personally?
Well,
best of Germany.
The best of, always. I did my PhD in Portugal, but we have some mobility programs, and I was able to stay in Germany, in Göttingen and in Gießen for more than 1 year. And it was an extremely rewarding experience. We had, as I said before, people from different backgrounds. We collaborate with each other. We did several activities together, unexpected activities like kayaking and hiking for several hours. And I enjoyed it so much that I decided to come back and embrace this Humboldt project. And also because Germany offers a very strong environment for chemists, because Germany has been a leader in chemistry along the years, and I think I'm in the perfect environment to do my research and to succeed.
Thank you. So chemistry and kayaking, so these are the
Yes.
main. Thank you, Elisa. I hope it works.
Yes.
Bronwyn, you arrived in Germany already a year ago. How was your experience in Germany differed from your expectations?
I didn't have too many expectations coming in.
Always good.
But I will say that I was mindful, as Australians, we have perhaps a reputation for being too informal in the workplace. So I was mindful of what workplace culture would be like here. But for me, it's been a very easy transition because my host institute, it's a research centre with, it's very multicultural, and it just is a very comfortable space for people from different cultural and linguistic backgrounds.
So you're from Melbourne, and now you are doing your research here there, in Bonn. Where, how is the adjustment to a German small town? How do you like it?
Bonn's not as small as people, but the things that I have been enjoying are cycling. As some of you may know, in Australia it's very big and far. So cycling, and I really like the supermarkets here. Yes, two very small random examples.
So how can we relate this now to our year's theme, Research Unites, also in connection to your research? How is the connection for you?
I wouldn't even have, well, okay. So when I first moved to Timor-Leste before my doctoral studies, my first friends there were actually from the German Civil Peace Corps. And so then I started to meet more German academics working in the Asia Pacific, and it was actually one of my examiners who recommended me to my host institute because he used to work there himself. So for me, it's kind of a triangle. I have now colleagues in the Philippines. University of Marburg has a research partnership also with the university that I do. It's, Timor, Australia, Philippines, Germany. Yeah. Bonn, yes.
Okay, so thank you. Thank you both for sharing your experiences with us, and thank you to the audience to have patience all this evening. We have some small gifts for you, and I think this is the end of the official part of the thing. We have one music more, I think. So thank you, and have a nice evening here in Forte.
Meine sehr verehrten Damen und Herren, wir nähern uns schon langsam dem Ende. Diese Veranstaltung folgt dem Prinzip der Deutschen Bundesbahn. Irgendwann kommt man schon an. Bevor wir aber zum nächsten Schritt übergehen, möchte ich 2 Dinge tun. Ich möchte mich ganz herzlich bei den Musikern bedanken. Das war super fantastisch. Dafür gibt es auch noch kleine Erinnerungen. Und zweitens möchte ich Sie ganz herzlich einladen, mit uns jetzt ein bisschen, sagen wir mal, Party zu machen. Also in Grenzen. Nicht ganz so wild. Aber ein bisschen Party muss schon sein, also sonst geht das nicht weiter. Und jetzt, weil es so schön ist und wir eigentlich schon fast in Partystimmung sind, würde ich doch vorschlagen, wir fragen die Musiker, ob sie nicht vielleicht noch ein Stück spielen möchten. Eine Zugabe bitte. Und dann Schluss, fertig, aus, nauf, es geht los. Vielen Dank. Vielen Dank. Das war das Richtige. Auf geht's, raus.